Hi students, today we are going to see analysis of electrical networks using Laplace Transform, and this is Vanilla from RMD Engineering College. So analysis of electrical circuits using Laplace Transform. So we are going to see the representation of electrical components, mainly resistor, inductors and capacitors in T domain and S domain. So here it is your resistor, and the current passing through the resistor is I of t, and then the voltage across your resistor is given as V of t. So how can we represent it in time domain? It's V of t is equal to R into I of t. So in S domain, after taking your Laplace for this one, so V of s is equal to R into I of s. So next is your inductance. So inductance, how can we represent it in your time domain? Means V of t is equal to L into di of t by dt. So S domain, after taking Laplace transform, so V of s is equal to L into, so differentiation of I of t can be written as S into I of s. The capacitance can be represented in T domain as V of t is equal to 1 by C integral I into dt. So after taking Laplace transform, it is 1 by Cs into I of s. So this is the basics. So now we'll see a problem here. Find the transfer function, frequency response, impulse response and step response of the system shown below. So this is the system. Here it is V of t is your input and V naught of t is going to be your output. So the output is collected across the capacitance. So the current flowing through the circuit is I of t. So by using your KVL equation, we can write the input equation as V of t is equal to R into I of t plus 1 by C integral I into dt. So we saw how to write your R and C in your time domain. Next, the output equation V naught of t is equal to, so it collected across the capacitance, so 1 by C integral I into dt. So taking the Laplace for both this equation, so V of t will becomes V of s is equal to R into I of s plus 1 divided by Cs into Is, and the output equation V naught of s is equal to I of s divided by C into s. With the help of these two equations, we are going to find the values here. So V of s is equal to R into I of s plus 1 divided by Cs into I of s. So I am going to take I of s commonly out. So I can write it out as R plus 1 by Cs into I of s. So from this one I am going to find the I of s value, which is nothing but V of s divided by R plus Cs. So the output equation that we got is V naught of s is equal to I of s divided by C of s. So in the problem statement they ask us to find the transfer function. So you know very well transfer function is nothing but output divided by input. So here output is V naught of s, input is V of s. So I'll be replacing this I of s with this equation. So I'll be getting it out as replace this I of s as V of s divided by R plus 1 by Cs. So V of s divided by R plus 1 by Cs, and already we have this Cs. So this is your V naught of s, which is equal to this one. So V naught of s, I'm just multiplying the C of s to throughout. So I can get it out as RCS plus the CS and CS get cancelled, so it becomes 1. So normally in the denominator in the S domain, the first term should be S. So I'll be taking the RC commonly out. If I take this RC, I got S plus 1 divided by RC. So in all your Laplace transform, the first denominator of the first term should be S. So for getting it is the required formula, I am just taking this R of C out. So now V naught of S is equal to V of S divided by RC into S plus 1 by RC. So V naught of S, we got it. So they asked us to find the transfer function. So V naught of S divided by V of S, output divided by input will be your transfer function. So V naught of S divided by V of S, which is nothing but the transfer function H of S is nothing but 1 divided by RC into S plus 1 by RC. Second component they asked us to find is frequency response. If I replace S as j omega in the transfer function, I'll be getting the transfer frequency response. So H of j omega is equal to, where and all I have S, I replace your S by j omega. So 1 divided by RC j omega plus 1 by RC. So impulse response, third component. So impulse response now find the output function V naught of s by equating the input V of t as del of t. So Laplace transform of del of t is nothing but 1. So your impulse response V naught of s will be equal to, I'm just taking this 1 by RC out, so it becomes 1 divided by s plus 1 by RC. So you have the formula inverse Laplace transform of 1 divided by s plus a is equal to e power minus at into u of t. So if I apply this formula here, I'll get the impulse response as 1 by RC into, so 1 divided by s plus a is nothing but 1 by RC. So e power minus 1 by RC t into u of t. So the last component is step response. So how I can calculate the step responses? I have to find the V naught output by equating your V of t to U of t. Right. So the Laplace transform of U of t is 1 by S. So V naught of S is equal to V of S divided by RC into S plus 1 by RC. So this is what we got. Now I am going to replace this V of S as 1 by S. So what happens here? I'll be taking this constant as 1 by RC as such, and this Bs is 1 by S. So S into S plus 1 by RC will be there in the denominator. Now I have to apply the inverse Laplace transform. So for that one, I'll be using the partial fraction method. So I equate this 1 divided by RC divided by S into S plus 1 by RC as A by S plus B by S plus 1 by RC, as I have two terms in the denominator. Now I have to find the value of A and B. Right. So after taking the LCM at this part, so A into S plus 1 by RC plus B into S, and then this two denominator will get cancels with each other. So 1 by RC is equal to A into S plus 1 by RC plus BS. So next is I am going to find the value of A and B. If I substitute S as 0 in this one, so 1 divided by RC is equal to A into 0 plus 1 by RC. So this B term will become 0. So this 1 by RC and 1 by RC will get cancels with each other. So your A value is going to be 1 again. So if I substitute your S as minus 1 by RC, what happens here is 1 by RC is equal to, this A term will become 0. So B will be B into minus 1 by RC. Now this 1 by RC and 1 by RC get cancels with each other. So B is equal to minus 1. So now I found the value of A and B as 1 and minus 1. So replace it in the equation. V naught of S is equal to A is replaced as 1, B is replaced as minus 1. So 1 by S minus 1 divided by S plus 1 by RC. So now take the step response by find the step response by taking the inverse Laplace transform. So your V naught of you know that Laplace inverse Laplace of 1 by S is going to be U of t, and 1 divided by S plus A is nothing but e power minus at into U of t. So applying this formula, I can write this V naught of S as V naught of t, and 1 by S as U of t, and 1 divided by S plus 1 by RC as e power minus 1 by RC t into U of t. So now we found a transfer function, frequency response, impulse response, and step response. So transfer function is output by input function. Frequency response is if you replace S by j omega in transfer function, you'll be able to get it. Impulse response is finding the output response by substituting the input as del of t, and step response is finding the output response equation by substituting your input as unit step u of t. Thanks for today. So you can subscribe my channel for automatic updates. Thank you. Have a nice day.